Welcome back, future engineers. Today we unlock one of the most powerful equations in physics. Maxwell's fourth equation, also called the Maxwell-Ampere law. Before we start, hit that like and subscribe button. Not because I asked, but because Maxwell deserves it.
Once upon a time in the world of science, electricity and magnetism lived like two powerful brothers, always arguing about who was greater. Electricity bragged, "I power cities, technology, lightning, I am the king," while magnetism folded his arms and said, "Without me, motors stop, compasses fail, and even you can't move properly." Scientists watched them like strict teachers watching naughty students. Then in 1820, in France, a calm genius named André-Marie Ampère entered the scene. He observed quietly, discovered that when electric current flows through a wire, magnetic field circles around it, and proudly wrote the law. Counter-integral B times dl equals mu naught I. Everyone celebrated, electricity smiled wide, "See? When I move, magnetism follows me like my bodyguard." Magnetism stayed silent, but deep inside, he knew the story wasn't finished. Time passed, and in 1861 at Cambridge University, England, a quiet, sharp-minded scientist named James Clerk Maxwell picked up Ampere's law and whispered, "Beautiful, but incomplete." He pointed at a charging capacitor. Electrons never cross the gap, yet magnetic field still exists there. If no current flows, how does magnetism appear? Nature never breaks its rules. Continuity must always exist. So Maxwell introduced a brilliant idea, displacement current, where changing electric field acts like current inside the capacitor gap. ID equals epsilon naught d phi e slash dt. With one stroke, he upgraded Ampere's law into a perfect, complete truth. Counter-integral B times dl equals mu I plus epsilon d phi e slash dt. Electricity's jaw dropped, magnetism smiled proudly, and Maxwell placed his pen like a king laying down a sword after restoring balance. Suddenly, a miracle happened. Electricity said, "If I change, I create magnetic field," and magnetism replied, "And if I change, I create electric field." They realized they were never enemies, they were partners. This is Ampere-Maxwell law definition. The magnetic field around a closed loop is produced not only by electric current, but also by a changing electric field. In formula form, counter-integral B times dl equals mu naught I plus epsilon d phi e slash dt. In this, counter-integral B times dl equals total magnetic field around loop. Mu naught equals magnetic strength of space. I plus epsilon d phi e slash dt equals total current, real current plus displacement current. In that moment of unity, light was born, not from wires or flames, but from electric and magnetic fields dancing together forever. That gentle correction written in 19th century England did not just solve an equation, it created sunlight, stars, radio, Wi-Fi, X-rays, satellites, modern civilization itself. And the universe whispered, nature never breaks continuity. Changing electric field creates magnetism. Changing magnetism creates electric field. They chase each other across space, making electromagnetic waves, the light that fills our world.
And that, my friends, is Maxwell's fourth equation, the law that united electricity and magnetism and lit up the universe. If this story made science feel simple and beautiful, subscribe, like and share with one friend so more minds can glow like light itself.